As we transition from our previous discussion, let's delve into the fascinating world of AI architectures and the ecosystem risks that come with them. In this segment, we'll explore the various AI development pipelines, which serve as the backbone of how we create and implement AI systems. Understanding these infrastructures is crucial as they encompass everything from data collection to model training and deployment. However, with innovation comes responsibility. We will also highlight the critical security challenges these modern AI systems face, such as data privacy concerns and vulnerability to adversarial attacks. Recognizing these risks is essential for anyone involved in AI development. Now let's move forward to grasp the complete journey of the AI development pipeline, illuminating each step from inception to production and the key considerations at every stage.
As we transition from our exploration of common AI architectures and the associated ecosystem risks, it's vital to understand the AI development pipeline. This pipeline represents the complete journey from the initial conception of a model all the way to its deployment in real-world applications. Recognizing this journey is crucial for identifying potential vulnerabilities and security gaps within our AI systems. Each stage, from data collection to model training and ultimately deployment, carries specific risks that can impact performance and reliability. In our next segment, we'll delve into model selection criteria, focusing on the key performance requirements such as accuracy, speed, and computational efficiency. These factors play a significant role in determining the success of an AI model, ensuring it meets both user needs and operational demands. Let's explore these criteria further.
As we move forward from our discussion on the AI development pipeline, let's delve into the essential criteria for model selection. Choosing the right model is pivotal, and it begins with understanding performance requirements. We need to evaluate accuracy, speed, and computational efficiency, ensuring these metrics align with our business objectives and technical constraints. Beyond performance, we cannot overlook resource constraints. Factors such as memory, processing power, and storage limitations play a crucial role in shaping our model architecture and deployment strategies. Equally important are security considerations, which encompass vulnerability assessment, data privacy requirements, and compliance standards. These elements significantly influence our model choices, ensuring that we not only achieve functionality but also maintain safety and integrity. Next, we'll explore the critical training procedures and best practices, starting with the vital process of data preparation. Let's get ready to dive into how we can effectively clean, preprocess, and secure our training data. As we transition from our discussion on model selection criteria, let's delve into the essential training procedures and best practices that ensure our models perform optimally. First, we focus on data preparation, which is critical for the success of any machine learning project. This involves cleaning and preprocessing datasets as well as securing them to protect data integrity and privacy. Ensuring that our data is accurate and reliable lays a solid foundation for the models we build. Next, we consider model architecture design. Selecting the right neural network structures and fine-tuning hyperparameters can significantly enhance performance. And we move on to training execution, where we implement secure environments equipped with monitoring and validation protocols to oversee the training process effectively. Finally, we validate performance by rigorously testing model accuracy, robustness, and security against potential threats. Now let's explore the fundamentals of deployment strategies, particularly the advantages of edge deployment. As we transition from our discussion on training procedures and best practices, let's delve into the fundamentals of deployment strategies. In the world of AI, the choice between edge deployment and cloud deployment is crucial. Edge deployment offers several advantages, particularly through local processing. With reduced latency, data can be processed almost instantaneously, which is vital for applications requiring real-time responses. Additionally, enhanced privacy is achieved as sensitive data can be handled locally, minimizing exposure. Offline capabilities further ensure that systems remain functional without constant internet connectivity, while a limited attack surface reduces vulnerability to cyber threats. On the other hand, cloud deployment provides centralized processing benefits. It allows for scalable resources, making it easier to handle varying workloads. With cloud solutions, updates can be rolled out efficiently, ensuring systems are always up to date. Lastly, centralized security measures help protect data more effectively. Next, we'll explore the infrastructure components that underpin these strategies, as modern AI systems rely on intricate ecosystems to function optimally. As we transition from discussing deployment strategy fundamentals, it's essential to recognize that the backbone of modern AI systems is a complex infrastructure ecosystem. This ecosystem encompasses a diverse range of components, including cloud platforms, specialized APIs, and innovative autonomous architectures. These elements work together seamlessly to support the deployment and scalability of AI applications. For instance, cloud platforms provide the necessary computational power and storage, while specialized APIs facilitate advanced functionalities, allowing developers to leverage cutting-edge machine learning capabilities. Understanding this infrastructure is critical as it lays the foundation for the effective implementation of AI solutions. In our next discussion, we'll dive into comparison of major cloud platforms, starting with Amazon Web Services and its robust array of AI and machine learning services, including SageMaker. So let's explore how these platforms contribute to the AI landscape. As we transition from our overview of infrastructure components, let's delve into the major cloud platforms that are shaping the AI landscape today. Amazon Web Services stands out with its comprehensive suite of AI and machine learning services, including SageMaker, which simplifies the process of building, training, and deploying machine learning models. Their extensive GPU instances support high-performance computing, while robust security frameworks ensure data protection. Moving on to Microsoft Azure, we find enterprise-focused AI tools that integrate seamlessly with Office applications. Azure's advanced cognitive services cater to businesses looking to enhance their operations while maintaining strong compliance with industry standards. Lastly, Google Cloud Platform excels with its deep integration of TensorFlow, offering powerful AI APIs and cutting-edge research capabilities through features like AutoML, which automates model building. Next, we'll explore specific AI APIs and services, starting with computer vision technologies that are revolutionizing image recognition and object detection. Stay tuned. Building on the insights we've gathered from our comparison of major cloud platforms, let's dive deeper into AI-specific APIs and services that are revolutionizing the way we harness artificial intelligence. First up, we have computer vision APIs. These powerful tools enable applications to recognize images, detect objects, and even analyze facial features. This capability enhances everything from security systems to social media platforms, allowing for a more interactive and personalized user experience. Next, we explore natural language processing. With APIs that analyze text sentiment, and translate languages, we can create systems that engage in meaningful conversations, making technology more intuitive and accessible. Lastly, speech and audio services bring voice recognition and text-to-speech functionalities into the mix. These advancements are essential for developing multimedia applications that respond to user commands with natural, human-like interactions. As we transition to our next topic, we will explore the exciting world of agentic architectures, where autonomous AI agents are set to redefine our interaction with technology. As we shift our focus from specialized AI services like computer vision, let's delve into groundbreaking advancement in artificial intelligence. Agentic architectures. Autonomous AI agents represent a significant leap forward, showcasing the ability to make independent decisions and execute tasks without the need for constant human oversight. This capability not only enhances efficiency but also opens up new possibilities for automation in various fields from healthcare to finance. Imagine systems that can learn from their environments, adapt to new challenges, and operate with minimal intervention. In our next discussion, we will explore the essential components of these autonomous AI agents, starting with their perception capabilities. Understanding how they sense and collect data from their surroundings is crucial to grasping their operational effectiveness. Let's dive deeper into this fascinating aspect. As we delve deeper into the fascinating world of autonomous AI agents, it's essential to explore their core components. At the heart of these agents lies perception, which encompasses environmental sensing and data collection capabilities. This allows them to gather crucial information about their surroundings, enabling them to understand and interact with the world effectively. Next, we have reasoning, which involves decision-making algorithms and logic processing. This is where the agents analyze the data they've collected to determine the best course of action. Following this, action comes into play, where the agents execute tasks and manipulate their environments based on their decisions. Finally, we have learning, which ensures that these agents continuously improve and adapt to new information and experiences, making them increasingly effective over time. With this foundational understanding, we can now transition to our next topic, large language models, which have significantly transformed the field of natural language processing. Let's explore how they fit into the broader picture of AI development. As we transition from our discussion on the components of autonomous AI agents, let's delve into large language models, or LLMs. These models have truly transformed the landscape of natural language processing, enabling machines to understand and generate human language with remarkable accuracy. However, this innovation comes with its own set of complexities and security concerns. Organizations leveraging LLMs must be vigilant, as the very scale and sophistication that make these models powerful also introduce unique vulnerabilities. Understanding these security challenges is crucial for ensuring safe and effective use of LLMs. In our next discussion, we'll explore specific threats, including prompt injection attacks, where malicious inputs can manipulate the model's behavior. So let's uncover how these security risks can impact the integrity of AI systems and what measures can be taken to mitigate them. Building on our previous discussion about large language models, it's essential to address the security challenges that accompany their incredible capabilities. One significant concern is prompt injection attacks. These involve malicious inputs designed to manipulate models' behavior, effectively bypassing its safety measures. Another challenge is data poisoning, where contaminated training data undermines the integrity of the model, leading to bias or even harmful outputs. We also need to consider model extraction, where unauthorized individuals attempt to reverse engineer proprietary models through systematic queries. Lastly, privacy leakage poses a serious risk, as it can unintentionally expose sensitive training data through the model's outputs and inference patterns. Understanding these challenges is crucial as we move forward. Next, we'll explore how retrieval augmented generation systems enhance LLM capabilities, blending pre-existing knowledge with real-time data for improved performance.
As we move on from discussing the security challenges posed by prompt injection attacks, let's explore an exciting development in AI: retrieval augmented generation systems, or RAG for short. RAG systems take the capabilities of large language models and elevate them by integrating pre-trained models with external knowledge retrieval. This powerful combination allows these systems to pull in real-time information from a structured knowledge base, ensuring that AI responses are not only accurate, but also current and contextually relevant. Imagine the potential here: more informed answers, enhanced problem solving, and an overall improvement in user interactions. As we delve deeper, we'll look at the essential components that make up RAG architecture, starting with the knowledge base, a structured repository of domain-specific information. So let's uncover how this foundation supports the whole system.
As we delve deeper into retrieval augmented generation systems, let's explore the key components that make up their architecture. First, we have the star knowledge base star, structured repository filled with domain-specific information and documents. This is where the system draws its insights, ensuring that the responses generated are not only relevant but also accurate. Next, we introduce the star retrieval system star. This is a semantic search mechanism designed to pinpoint the most pertinent context for any given query. It's like having a highly skilled librarian who knows exactly where to find the needed information. Finally, there's the star generation model star, which is essentially the large language model that takes the retrieved data and synthesizes it into coherent, meaningful responses. Together, these components work harmoniously to enhance the overall effectiveness of RAG systems. In the next slide, we'll discuss an important aspect of RAG systems: security vulnerabilities, particularly the risks associated with retrieval poisoning. Let's dive into that. As we transition from our previous discussion about the key components of RAG architecture, let's delve into an important concern: security vulnerabilities related to retrieval poisoning. Retrieval poisoning occurs when malicious documents are deliberately injected into knowledge bases, which can corrupt system responses and spread misinformation. Imagine a scenario where an AI system provides flawed or harmful information, all due to the influence of these corrupt documents. Additionally, attackers may manipulate context, exploiting retrieval mechanisms to introduce harmful context into the generation processes. This not only jeopardizes the integrity of the information provided, but also poses significant risks to decision-making and trust in AI systems. Now let's explore another critical aspect of AI security: the risks associated with third-party AI tools, which are becoming increasingly prevalent in organizations today. As we transition from our discussion on RAG security vulnerabilities, let's explore the risks associated with third-party AI tools. Today, organizations are increasingly turning to external AI services to enhance their operations. While these tools can offer significant advantages, they also create complex dependency chains that can expose organizations to various security vulnerabilities. When relying on third-party AI solutions, businesses may inadvertently introduce points of weakness into their systems. This interdependency means that if one service is compromised, it can have a cascading effect, potentially impacting multiple areas of the organization. Understanding these risks is crucial for maintaining robust security practices. In our next segment, we will delve deeper into some common risks associated with these third-party AI services, particularly focusing on API dependencies. Let's continue to uncover how we can better safeguard our systems in this evolving landscape. As we transition from discussing the risks associated with third-party AI tools, let's delve deeper into some common concerns that organizations face when relying on these external services. First, consider API dependencies. Integrating with third-party AI services creates potential points of failure. If an API goes down or experiences issues, it can disrupt your operations and lead to data exposure risks. Next, we have vendor lock-in. Overdependence on specific providers can limit your organization's flexibility, making it challenging to adapt or switch services in the future. This reliance may also elevate your long-term security risks as you become more tied to a single vendor. Lastly, we must address data sharing. When sensitive information is shared with third parties, there is always risk that it could be stored, processed, or utilized in ways you never anticipated. In our next segment, we'll explore the transparency benefits of open source models and how they can enhance your approach to AI. As we transition from discussing the risks associated with third-party AI services, let's delve into the considerations surrounding open source models. One of the key benefits of open source models is transparency. They provide valuable visibility into their architecture and training processes, allowing for thorough security audits. This can significantly enhance trust and accountability within AI development. However, it's important to be aware of community vulnerabilities. The public availability of these models can attract scrutiny, which unfortunately also opens the door for potential exploitation by bad actors. Additionally, maintenance challenges arise. Ensuring long-term security updates and patches often relies on community involvement and the sustainability of the project. With these considerations in mind, let's explore the critical topic of dataset security challenges. After all, the integrity of training datasets forms the very foundation of our AI systems.
As we transition from the importance of transparency in open source models, let's delve into another critical aspect: dataset security challenges. Training datasets are the very backbone of AI systems. Their integrity and security are not just technical requirements. They are essential for ensuring the trustworthiness and performance of the systems we build. If the data is compromised or biased, it can lead to flawed outcomes, undermining the very purpose of AI technologies. This means that we must be vigilant in how we handle and protect our datasets. Understanding the security challenges and potential vulnerabilities is paramount for developers and organizations alike. Next, we'll explore the various risk factors associated with data collection, particularly how unverified sources can introduce biases or inaccuracies. So let's take a closer look at what we need to watch out for.
As we transition from discussing the security challenges faced by datasets, let's delve deeper into the specific risk factors associated with data collection, storage, processing, and sharing. First, consider data collection. Utilizing unverified sources can lead to the introduction of biased, inaccurate, or even malicious content, ultimately tainting the integrity of our training datasets. Next, data storage is critical. Without adequate security measures, we risk unauthorized access and potential tampering, which can severely compromise the dataset's reliability. When it comes to data processing, errors or intentional modifications can corrupt data quality and negatively impact model performance. Lastly, sharing datasets can introduce hidden vulnerabilities or privacy violations that must be carefully managed. With these risks in mind, it's essential to adopt a comprehensive approach to manage AI supply chain security effectively. Let's explore that next. As we transition from discussing the risks associated with unverified data sources, let's shift our focus to a crucial aspect of ensuring the integrity of AI systems: supply chain security. Managing AI supply chain security requires a comprehensive approach that addresses vulnerabilities throughout the entire development and deployment lifecycle. This means looking beyond just the immediate technology and considering the broader ecosystem, including the various players, processes, and tools involved in creating AI solutions. Understanding this framework is essential as it helps organizations identify potential weaknesses and implement effective safeguards. By doing so, we can ensure the reliability and safety of AI technologies, ultimately fostering trust and resilience in our digital environments. In our next discussion, we'll delve into the key components of supply chain security, such as risk assessment, vendor evaluation, and dependency tracking, which form the backbone of robust security strategy. Building on our previous discussion about the AI supply chain security framework, let's delve into the critical components that make up an effective security strategy. First, conducting a thorough risk assessment is essential. This helps identify vulnerabilities and prioritize areas that need immediate attention. Next, evaluating your vendors is crucial. A thorough vetting process ensures that third parties uphold the same security standards you do. We must also be vigilant about dependency tracking. Understanding your reliance on various tools and services can help anticipate potential risks. Continuous monitoring plays a key role in this, allowing you to detect threats in real time and respond promptly. Lastly, having a robust incident response plan ensures you're prepared to act swiftly should a security breach occur. As we move forward, we'll explore best practices for implementing a defense in depth strategy, which layers multiple security controls to safeguard your AI systems effectively.
As we transition from our previous discussion on the key components of supply chain security, let's explore best practices for safeguarding our AI systems. Implementing a defense-in-depth strategy is essential. This means establishing multiple layers of security controls across all components of your AI systems. By doing so, we can significantly reduce the risk of any single point of failure. Continuous monitoring is another crucial element. Real-time systems can swiftly detect anomalies and potential security breaches, allowing for prompt responses to any issues that arise. Additionally, keeping our security patches and updates up to date is vital. This practice ensures that all infrastructure components and dependencies remain secure against emerging threats. With these best practices, we can strengthen our defenses. Next, we'll delve into effective risk mitigation strategies, focusing on areas such as model attacks, data breaches, and third-party APIs. Stay tuned. Building on our previous discussion about best practices for AI security, let's delve into the critical topic of risk mitigation strategies. This slide illustrates the diverse landscape of AI security risks: model attacks, data breaches, supply chain vulnerabilities, and threats from third-party APIs. The graph showcases the impact level of these risks alongside the effectiveness of current mitigation strategies. As we can see, each category poses unique challenges, and understanding their relative impact is essential for prioritizing our defense efforts. By identifying which areas require more robust measures, we can tailor our security protocols to better protect our AI systems. As we transition to our next slide, we'll explore the key takeaways that underline the importance of a holistic security approach. After all, addressing AI security comprehensively is not just beneficial, it's imperative for safeguarding our technology and data.
As we transition from our discussion on risk mitigation strategies, let's delve into the key takeaways that highlight the importance of holistic security approach in AI. First, it's essential to recognize that AI security is not just about protecting individual components. It requires comprehensive strategy that encompasses the entire ecosystem. From development through deployment, this means integrating security considerations at every stage of the AI lifecycle. Next, given the ever-evolving threat landscape, continuous vigilance is crucial. Organizations must commit to ongoing monitoring, regular assessments, and the ability to adapt security measures swiftly in response to new threats. Finally, effective AI security thrives on collaboration. It's vital for developers, security teams, and the broader AI community to work together, sharing insights and strategies to strengthen our defenses. Our next slide will explore practical steps to implement these strategies effectively.